Hi, this is K.Hari Babu, working as Associate Professor of EC Department in MLR Institute of Technology. Today, I want to discuss about binomial distribution and density function along with problems. So, first of all, binomial distribution and density function. So, here binomial means consider any experiment having two outcomes. Those two are either true or false, yes or no, 1 or 0. These are the events in this experiment. Now, if the same experiment is repeating n times, is called Bernoulli trial. So here, for example, the successive probability of the event is assumed to be p. Then find the probability of event A occurs exactly k times. So we can write the probability of event A occurs exactly k times. So we can write P of k equal to NCk into P power k into 1 minus P whole power n minus k. So this is finding the probability for exactly the event A occurs exactly k times. So here what is meant by NCk? Here NCk is called binomial coefficient, that is n factorial by k factorial into n minus k factorial. So this is the binomial coefficient by using Bernoulli trials. So now we need to know about this binomial and Bernoulli. So here it contains somewhat rules. First rule, for example, if n is very large and k also very large and n minus k also very large, in this case, we cannot find the n factorial value. So that's why we are using Stirling formula. So in this case, to do this type of problems, we are using de Moivre Laplace approximation. That is, n is very large, k is very large, n minus k also very large. We are using de Moivre Laplace approximation. So now, what is this de Moivre Laplace approximation? See here, that is, the probability of event A occurs exactly k times. In this case, by using de Moivre's Laplace approximation, 1 by square root of 2 pi np into 1 minus p into e power minus of k minus np whole square by 2 np into 1 minus p. So this is called as de Moivre Laplace approximation. We know already second one also, that will be used for Poisson approximation, that will be using the Poisson probability distribution density function. In that case, we know if n is very large, p is very small. But in this case, we are using n is very large, k is very large and n minus k is very large. We are using de Moivre Laplace approximation. Now, we need to discuss about binomial probability distribution and density function. So here, binomial probability distribution function, that is fx of x is equal to summation of k equal to 0 to n nck into p power k into 1 minus p whole power n minus k with del of x minus k. So this is binomial probability density function. Now we need to define binomial probability distribution function, that is fx of x is equal to summation of k equal to 0 to n nck into p power k into 1 minus p into power n minus k into u of x minus k. So this is binomial probability distribution function. So what are the applications of this binomial probability and distribution density function? Mainly these will be used for gaming chances and detection problems, radar and sonar. These type of problems we are using binomial to detect the radar and sonar. We are using this type of binomial. So now we are moving to the problems related to this binomial probability distribution and density function. See here, an aircraft is used to fire out of a target. Aircraft is used to fire out of a target. Now, it will be successful if 2 or more bombs are hit the target. Now, the aircraft is hitting the target. It will be successful when 2 or more bombs are hit the target. For example, I want to find K is greater than or equal to 2. So, means hitting the target will be taken as either 2 or more than 2 bombs are hit the target. That is K greater than or equal to 2. Now, if the aeroplane fires 3 bombs, So, here the total number of bombs are 3 are there, n equal to 3. And the probability of bomb hitting the target is 0.4. So, that is successive probability P of A is equal to, that is P is equal to 0.4. Now, what he is asking then, what is the probability of to fire out the target? So, now you need to find the probability of K greater than or equal to 2. What is the value of this one? See here, total number of bombs are 3. If hitting the target, successful rate will be taken as K greater than or equal to 2 and P value is 0.4. All these will be taken as normal, means I need to use directly binomial function, that is P of K greater than or equal to 2 means generally we know what we know, that is NCK P power K into 1 minus P whole power N minus K. So, now I can write P of K greater than or equal to 2 is equal to summation of K equal to 2 to 3 number of bombs, total number of 3, K equal to 3 and P, here P will be taken as 0.4 power K and 1 minus P, 1 minus 0.4 whole power N minus K. Now, I need to expand this summation. I can write first K equal to 2, that is we can write, NCK, that is 3C K equal to 2, first 3C2 0.4 power 2 into 0.6 power 3 minus 2 plus next K equal to 3, that is 3C3 0.4 whole power 3 into 0.6 whole power 3 minus 3. So, if you want to solve this one, you can get 0.35. So, this is the bomb hitting the target is 2 or more than 2 will be taken as 0.35. Now, we are moving to the next one. See here, a production line manufactures 5-gallon gasoline cans or tins to volume tolerance of 5%. The probability of any one tin being out of tolerance is 0.03 if 4 tins are selected randomly. Now, he is giving the data about, we have 4 number of tins, that is total number of tins are 4. Next, what he is giving, the probability of any one tin being out of tolerance is 0.03. So, now our main probability event will be taken as out of tolerance. So, here the out of tolerance will be given as 0.03. Here P is assumed to be out of tolerance. Then the P value is given as P is equal to 0.03. We know N value, we know P value. Next, what he is asking, what is the probability that there are all out of tolerance. All are out of tolerance. So means I have 4 number of tins. Those 4 are out of tolerance. Means simply I need to find the probability of exactly 4 tins are out of tolerance. That is K equal to 4. First bit. That is P of K equal to 4 means we know already formula, that is NCK. That is NCK P power K into 1 minus P whole power N minus K. So here what is N? 4. C K. K equal to 4. What is P value? That is 0.03 power K is 3 and 1 minus 0.03, that is 0.97 power 4 minus 4, that is 4C4, 0.03 power 4 into something power 0, that is 1. So that is, it is approximately equal to 8 into 10 power minus 7. So here 4 tins are out of tolerance. Next one, what is the probability of exactly 2 being out of tolerance? Only 2 tins are out of tolerance. So we need to find P of K equal to 2. 2 tins are out of tolerance. We need to use same formula, that is NCK P power K into 1 minus P whole power N minus K. So here K equal to 2 means we can write 4C2 0.03 power K is 2 and 1 minus 0.03 power 4 minus 2. So this is approximately 5 into 10 power minus 3. Next one, what is the probability that all are out of tolerance? All cans are out of tolerance. See here, sorry, all cans are intolerance. 4 cans are intolerance only. So here we know N value, N equal to 4, P equal to 0.03. Now what he is asking, you need to find the probability of all cans are intolerance. So means what is our probability of event A will be taken as all cans are out of tolerance. Cans out of tolerance is given as 0.03. Now he is asking, you need to find the probability for all are intolerance. So means simply we can write K equal to 0. There is no tin or out of tolerance. That's why K equal to 0. So we need to find P of K equal to 0. We know already formula, that is NCK P power K into 1 minus P whole power N minus K. See here, N is 4, 4C0, P 0.03 power 0 into 1 minus P, that is 0.03. This value is 0.97 power 4 minus 0. So here that also equal to 4C0. So value is 1, that is 0.97 power 4. So this is approximately 0.88. So this is the all cans are intolerance. Next we will see another problem. See here, a fair coin is tossed 200 times. A fair coin is tossed 200 times. Here N is given. Find the probability that head will show 100 times. Here my probability of event will be taken as head will show 100 times. P of A is equal to 100 times. So here the event A, K is equal to 100 times. See here, he is giving fair coin. Coin contains only 2 outcomes only. We can generate either or head or tail only. So now it is fair coin means what is the probability for each one? This will be taken as each equiprobable value. That is, probability of head is equal to probability of tail is equal to 1 by 2 only. So here my probability is assumed to be head means success probability will be taken as 1 by 2. It will show 100 times exactly. Here K is equal to 100. Now I need to find probability of K equal to 100. See here, N equal to 200. k equal to 100 and n minus k is 100. 200 minus 100. 100. Here n is very large, k is very large and n minus k also very large. All these three values are very large means we cannot find n factorial directly. It is very difficult to find that n factorial by using binomial coefficient. That's why we know already one rule, that is de Moivre Laplace approximation. By using that one, I can write probability of event A occurs exactly k times is equal to 1 by square root of 2 pi np into 1 minus p into e power minus of k minus np whole square by 2 np into 1 minus p. So, this is the de Moivre's Laplace approximation. Now, I need to substitute all these values in this one. I can write probability of the head wheel occurs exactly 100 times means probability of 100 is equal to 1 by square root of 2 pi into n. N is 200. 200 into p is 1 by 2 into 1 minus p also 1 by 2 into e power minus of k. Here k will be taken as 100 minus n value 200 into p 1 by 2 whole square divided by 2 n 200 p 1 by 2 into 1 minus 1 by 2. See here, that is 100 to cancel. We can write 1 by square root of 100 pi into e power minus of 100 minus 200 into 1 by 2, 100 only. 100 whole power 1 by 2 divided by 2 np. 2 into here 2 cancel and 1 by 2 here also cancel, will be getting as 100 only. See here, e power 100 minus 100, 0. E power 0 means its total value is 1 only. So, here answer is 1 by 10 into square root of pi. So, this is the probability of head wheel occurs exactly 100 times is 1 by 10 root pi. Now, we are moving to the next one. That is, a machine gun fires 3 seconds. That is, time is given 3 seconds at the rate of 2400 bullets per minute. So, here rate is given. Rate, that is 2400 bullets per minute. So, here by using this one, I can find how many number of bullets are used for this one. So, here I can find by using this rate and time, I can find the number of bullets. N is equal to 2400 bullets per minute. I want to convert in terms of the second, that is 60 seconds into time is 3 seconds. So, here it will get 120. So, here total number of bullets are 120. N is given. Now, the probability of bullet hitting the target is 0.4. Hitting the target probability, that is event A, probability of event A, successful event, that is P is equal to 0.4. Now, what is the probability of exactly 50 bullets hitting the target? I want to find the probability of K is equal to 50. 50 bullets hitting the target. See here, I know N value, N is 120 and K equal to 50 and N minus K. N minus K is 120 minus 50. So, this is also large value only, 120, 50, 70. For this one, probability means, that is factorial will be somewhat difficult to find. Why? Because all these values are very large. In that case, this is also belongs to binomial only. Now, by using de Moivre Laplace approximation, we can find, that is probability of event A occurs exactly k times, that is P of k equal to 1 by square root of 2np into 1 minus p into e power minus of k minus np whole square by 2np into 1 minus p. That is probability of k 50 is equal to 1 by square root of 2 pi np. 2 pi into n is 120 into p 0.4 into 1 minus p means 0.6 into e power minus of k 50 minus n is 120 into p 0.4 power 2 divided by 2 into n 120 0.4 into 0.6. So now the probability of 50 will be getting as approximately 0.0693. So this is the value for this. Yeah. Thank you.